We are fortunate because we understood what the batteries is. And let me explain to you what the batteries are. Batteries have three components. The first cost is the battery material. Almost 40% of the cost of the battery comes from battery material. Lithium, manganese, cobalt, nickel, graphite, all of them play a role. There are other things which play a role. Then you make battery to cell. That is what we are going to start making. That is actually a small value at 20-25%, cell manufacturing. That is where we need to do that in India. 40% material we have to look at it. Cell to pack manufacturing also has 35% value. This is not understood. Most people thought they will buy cells and assemble it. The cells are designed to operate optimally at 25 degrees centigrade. Batteries have to operate at 45 degrees centigrade. What kind of thermal design will you do? Very, very important for Indian conditions. Remember, temperatures in Germany, much of Europe, in China, United States is much lower. They do not see 45 degrees centigrade. They do not do research work of how do you design a battery pack for 45 degrees centigrade. We have to do that. That is the first thing that we have to do. Second, even day before yesterday somebody asked me, why should mechanical design matter of a battery pack? You know, again, if you go to Europe, United States and much of China, the roads are fairly smooth. The vehicles do not vibrate so much, do not have this bumps. Out here, our roads can become so bad as soon as you go away from highways and the main roads in the city, you keep on lot of vibration. Now, a cell is somewhat like a cell phone, could be bigger, somewhat like this, but it is a similar kind of often plastic package, sometimes soft package also, but it is like this. Every time you charge and discharge, the battery puffs up and goes down. Actually, the battery puffs up and goes down. In fact, there is so much of force that even if it is made of metal, metal tends to bulge and compress. So, you put cells next to each other, they will be putting pressure on each other. Now, you can design it such that they put some pressure is good, but because you want to prevent it bulging too much, but you do not want too much pressure because it hurts the battery life. But now, take this same battery, put it into a vehicle and go through the back roads of a city, forget about smaller towns and villages, the vehicle jumps all over, vibrates. Now, all these cells which are packed, all screwed, and with the right pressure, they start vibrating. Very, very difficult problem. The life can go for a toss. Mechanical design, taking into account vibration is critical. The third thing which I have not emphasized, in a later point I will emphasize here, is the electrical management. You know, something that we learnt hard way. Very often our smaller batteries have currents of 100 ampere to 200 ampere. When you have such high current, even a milliohm path difference, there are two paths, there are conductors, current can go this side, that side. A milliohm path difference can mean 0.1, 0.2 volt drops. And all these batteries operate with 0.56 volt charge to discharge. You get a totally different picture of what is actually happening. Your strategy for charging, discharging goes for a toss and you can get into serious trouble. So, you need a very good electrical design. And finally, the BMS, battery management system. battery management systems task is twofold. We will get into details of that. First is protection, safety, second is cell balancing, because cell becomes imbalanced. Why it becomes, we will look later on. So, cell to pack manufacturing we have to do as per Indian condition, and this is a value add we can do today, and we are already doing it. The second is cell manufacturing. Now, this is a complex task, because while the manufacturing plant does not change, the chemistry changes every 2 years. So, this is where a lot of R&D is required, and if you have everything ready today, manufacturing and selling doing well, 2 years down the line if you do not come with new chemistry, you are outdated, your plant will go for a loss, nobody will buy from you. So, you need continuous R&D, and unfortunately our R&D is not giving us the latest battery chemistry. So, it is here we need to tie up with someone, enhance our R&D capacity so that we stay ahead. The third is materials, it is mostly important. This is the question that was asked, 40% value of the battery you are going to import. This is where we started working. A lot of material that is used, lithium, manganese, cobalt, nickel and graphite, sometimes iron and phosphate. India does not have much of the mines for this. Import bill could skyrocket, because we are going to hit 25 gigawatt hour, not by 2025, even before that. Now we are going to use battery also for grid. So, we are going to, this is the way our usage in terms of gigawatt hour of battery and disposal of battery will go on. So, what do we really need to do? Well, this is where over the last 5 years we have solved the problem that was asked. We have started to learn to recycle batteries. We are calling it urban mining, because it is like a mine, it gets back my lithium, cobalt, nickel, manganese from the waste, battery waste, from a old battery, and we are able to today recover almost 90% of the material. We have a small pilot plant sitting here in IIT Madras Research Park. We have also the some startups doing that, recycling and recovering 90% with near zero effluent is extremely important. We can't have, that is a bad part. If you can create effluents, there are many who are doing it. We are doing a process that which has a near zero effluent. India could soon import used batteries, not the material, and recycle and recover and reuse the material, and this is what we need to do. 100,000 ton battery waste will be available in India today, which is already 20 gigawatt hour of batteries. This is from cell phone batteries. These are also lithium ion batteries. We are throwing away 300 million cell phone batteries every year. If we recycle, we can make gold out of it. Then we have to worry about second life of batteries. Remember that once it reaches 85 to 75% of initial capacity, it is no longer useful in electric vehicle, range will go down. We will take these batteries out, and from 80% to 50% we can use it as energy storage. Most of our homes and offices have power outage, we use UPS, these batteries can be used there. A challenge is how to design EV batteries to enable usage of second life, how to refurbish battery for second life, and after second life recycle. This is what we really need to do, and we have to learn to monitor the capacity continuously, and as the battery life goes to 80 or 75%, take it out of the vehicle, then use it for second life. As it goes down to 50%, take it out for recycling. This is a challenge that we need to overcome. This brings me to the last subsection of chapter 1b. It is simply listing of EV subsystems, each of which we will cover either in part 1 or part 2 or part 3 and 4. Can we shut off the air conditioner? For example, a petrol vehicle, internal combustion engine drivetrain to EV drivetrain, what are the common parts? Body and frame will be there in petrol vehicles, electric vehicles. Strictly speaking, no need to change them. But let me tell you, over time, petrol vehicles require a little heavier body and frame. Electric vehicles will require lighter body and frame, and therefore one can change that. But for the time being, we don't need to worry about it. Similarly, doors and power windows, we can use existing ones. Wheels, including rim, hub, knuckles and tires. The one point I want to make, better tire you use, lower the rolling resistance. Lower the rolling resistance, higher will be the range. Higher the range for a given battery, you can reduce the battery size. You reduce the battery size, cost comes down. So in fact, one will like to use better tires. Always choose better tires. Suspension system, existing system including the lower arm and the struts, there is no particular need to change. Power steering system, it used to be hydraulic some time back, 15 years, 10 years back, started moving to electric. In fact, petrol cars have been becoming slow, step by step electric. So already hydraulics converted to electric, that can straight away be used. Power steering systems, we certainly don't need hydraulic. Power braking system, again, it started with hydraulic braking, particularly for trucks and things like that. Now it is electric. Vacuum pump to actuate the braking, electric vacuum pump. Fortunately, this work has been done, it can be used. Safety system, all airbags, parking sensors, lights, all of them are electrically driven. Wipers and fluid pumps, existing, can be used, no need to change. Mirrors, and now mirrors are adjustable electronically, great. Manual mirrors are also there. Interiors, all interiors including seats, seat belts, AC vent, cabin lights, other interior components, we don't need to change any of these things. These are things, if you are making them, you can continue to make them, you can improve them. Always keep in mind, what improvement can I make now that I have an electric vehicle, but these are industry which will survive. Which are the parts and components to be modified? Air conditioner system can be modified. Today we are using hydraulic actuated AC compressor. Virtually all of them are using hydraulic. Hydraulic power comes from vehicle movement by a petrol pump. We don't need that. We can directly use DC motors. And the rest of the air conditioner can be as it is. This is something we quickly can do. Cooling system. That cooling system can be used from motor, air conditioning and cooling system, motor and batteries with electric water pump integration. Dashboard will need some modification because now you have to display different things, but same electronic displays we can do. The parts which will go out completely, fuel tank, no place, you are not going to have fuel tank. Remove fuel tank and associated connections. Engine will go out. Remove engine and all associated, that is a major moving parts removal. Clutch and transmission. Generally we will have a single speed we will have a system without movable gears. So, you will not need clutch and transmission. ECU and connections with other sensors, fuel pump and other engine systems, all of them will no longer be required, will directly be driven from electric vehicles. What are the new ones? Electric motor and controller, high performance electric motor used for traction, motor controller for motor drive with closed loop feedback system. They are very critical components. This is something that we need to make in India. Transmission system, high energy transmission system with reduction system for high acceleration. Normally the electric motors will give you fairly large range of torque and speed, depends on that, also will evolve, will take 4 or 5 years before you can get there. Intermediate you may have a few gears, not too much. Battery pack with BMS is going to be a very important component. That is a replacement of fuel tank. Reliable battery pack with BMS with all kind of CAN communication and support. Then IoT and telematics. In fact, this is getting added today even for petrol vehicles. But IoT can do more easy. You can do all kind of vehicle data combined with latest technology of telematics and infrastructure to monitor and manage the vehicle remotely. This is already happening with petrol vehicles, it has to get accelerated. You will need number of DC-DC converters. Battery will be a certain fixed voltage. Could be a 48 volt for small vehicles, 350 volts for medium size, 650 volts for large size vehicles. We will go through that. But you will need smaller 12 volts, 5 volts, other devices will be that kind of voltage. So, you will need DC-DC converters for peripherals. You will need a vehicle control unit and master control unit, can be integrated with motor controller, but can also be separate, and it will also record your management, safety. This is the one which will do all the communication. So, that is what is required. There will be isolation circuits required for vehicle and user safety, particularly if you are going to use 350 and 750 volt, you require two parts, one which will be 350, that will be totally isolated from the rest of the vehicle. Charging infrastructure is new, charging ports, charging system for vehicle, you will require both onboard chargers and external charger, and of course software and remote monitoring, lot of that will be added. This is what the new vehicle will look like. Towards the end, let me also talk about some other aspects which we will also discuss during this course. There is a very important concept which I had already introduced, a concept of regeneration. What does it mean? I recover the electricity used. I drive the motor, I consume certain energy. I slow down the motor, I recover energy during deceleration, braking, descending, and I convert that to electrical energy and charge back the battery. This is regeneration. So, motor designed to recover as much energy as possible, it has to act as a regenerator. How much can I recover? For example, suppose I could recover 100% of energy, it is 100% regeneration. My climbing up will always be compensated by climbing down. My accelerating will always be compensated by decelerating, because if I am accelerating, sometime I have to decelerate. If I have climbed up, sometime I have to climb down. So, my climbing up energy requirement is temporary, my accelerating energy is temporary, and I will recover back. That is if I could recover 100%. If I can recover 90%, not bad, close to that. Today, very often 30-40%. We need a long way to go. This is the future task. Vehicles will then use own energy If I could recover almost 90%, then I only need to use energy in rolling resistance in aerodynamic drag. Acceleration and deceleration does not require energy. This is what the next 5-10 years will tell. Materials for lightweighting vehicles, because you may not require as heavy a vehicle, you do not have petrol, as many moving parts, petrol vehicles. Better materials for better insulation become very important to reduce heat load, because your air conditioner, where will it derive energy from? From the battery. Where is today's energy is derived from for air conditioning? From petrol pump, petrol. But petrol is, you buy petrol, you have large petrol pump tank that does not have, you can fill that up and use part of the energy. Okay, your cost will go up, but you are not depreciating, there is no range anxiety. In a battery, if you use substantial energy for air conditioner, then you will cause range anxiety. So, better insulation to reduce heat load, that will become very important. Better tires, so that better aerodynamics, so that energy efficiency of electric vehicles is increased. Vehicle controller and software, it will continuously improve. We are just getting the first generation, integration and testing, all this will be an important part. A challenge will be, can we rethink of a vehicle, forget about petrol vehicle and rethink, because it's electric. Otherwise, we will always be conditioned by ICE vehicle, petrol vehicle, and we will try to replicate that. Can we totally rethink of a vehicle? Very interesting exercise, someday we should do this. This is what we need to do, and with this I come to the conclusion. Remember, we have to move to electric vehicle ASAP. 2030, significant progress, mostly we are there. If we need to make things as per our requirement, we want to stop import, we stop importing of vehicles, electric vehicles. We need to make electric vehicles and move fast. In 3-4 years, they will become cheap enough, they will get imported, smuggled in. We have 2 to 3 years time to design and manufacture EV subsystem. We have to flesh out what we will do in first year, second year and third year. Not just development, but commercialize and scale. We have to ask question, what will be the role of startups? What will be the role of R&D personnel in educational institute, R&D personnel centers, what they have to do? What is the industrial R&D will be? How do industry and academia work together? What do we need from the government? Unfortunately, these questions are not being answered. I strongly believe we will do most of it by 2030, and I am giving you one article, IEEE Electrification Magazine. It is a couple of years, 2 years old, or probably more, 3 years old article, but still very relevant. And 5 years back I had written a blog called Understanding the EV Elephant. You search for it, you can still find it. While part of it could be rewritten, but still it gives you a lot of very interesting insight if you want to look at it. So, with that, the introduction that we have in part 1 is over, and this is also introduction to part 1, 2 and 3 and 4. A detailed introduction, substantial, because this introduction itself can get you started, get a fairly decent understanding, and then you can start ticking boxes from here. I now learn this, I now learn this. Everything that we will now teach will be modular. In part 2, we will go into vehicle dynamics, something which is common to electric vehicles and petrol vehicles, but we will emphasize the electric vehicles. After that, we will start getting into each subsystem, get into a little bit of design parts in chapter 3, and then plunge into batteries, then plunge into motors and controllers, plunge into chargers, put it all, stitch it all together, will be part 1, 2 and 3, and in part 4 we will get into renewable energy in Indian context. Thank you very much and see you with chapter 2 in the next class. Magazine I have given as a reference, I have given the blog as a reference, I have given 2 very interesting reports, WRICB report and Niti Aayog report. All these reports will give you a fairly good idea of electric vehicle in Indian context. Please look at that for more reading. Thank you very much.